Okay, so we're going to watch another video and I'm going to work some problems out together. So if you could have your limiting reactant notes out and follow along in the notes as you watch the video. So remember, your limiting reactant is going to be basically controlling your reaction. One of your reactants is the limiting, the other reactant is considered to be in excess. Once the limiting reactant is used up, the reaction is going to stop. And the other reactant, the reason why it's called excess, is you're going to have some left over because it's not all completely used. Um, so I'll give the analogy of making cookies. Okay, so basics that you need for most cookie recipes would be your flour, your white sugar, your brown sugar, and so on. Okay, so let's just say we're making Christmas cookies. And for each one of our cookie batches, our recipe or our reactants would be your flour, your white sugar, your brown sugar, and so on. But let's say we run out of flour. That flour is going to be your limiting reactant in this case because you can't make any more cookies until you go and purchase more flour. So, in the chemical world, it would be really, really nice if we could see all of our atoms and molecules at the microscopic level, and it would make it so much easier and quicker to determine which one was your limiting reactant. So let's say we are working with four molecules of diatomic hydrogen and four molecules of diatomic oxygen. And this is our balanced equation. For the equation here, we have two molecules of diatomic hydrogen plus one molecule of diatomic oxygen would make two molecules of water. Okay. But we have four molecules of diatomic hydrogen, and two molecules of water will be needed out of the four. And we're going to end up making four molecules of water. Okay, so if you could see this, these are the two diatomic oxygen that are left over because these two diatomic oxygen, they're going to split and they're going to combine with your two hydrogen. And here's your four water molecules that you have made, and your oxygen is left over. So in this case, hydrogen is your limiting reactant because it's all going to be used up to make your four water molecules over here. Your oxygen is considered to be in excess because you have two molecules that are left over. So I'm going to pause right here, and I would like for you to get out your help packet. And towards the beginning of your help packet, you are going to see the steps for limiting reactants. So if you keep these steps in mind, you will be able to set up and solve them very easily, and you'll be able to use this on your quiz and your test. So the limiting reactant is most of the time when you're working with lab, you're not working with, oh, I have 5 moles of this and 2 moles of this. You're either going to be measuring out a volume or a mass, and you have to convert your volume and your mass over to moles. Then we go with a step that's called convert to compare. And then from that step, we'll determine which one is the limiting versus which one is the excess. And once you know which one is your limiting, you will use your limiting reactant to solve for the other parts of your question, like how much of your product are you going to make? Or if this is my excess reactant, how much of my excess reactant will I use and how much will I have left over? So let's take a look first at our first example. So I'm giving you your balanced chemical equation where we have magnesium reacting with oxygen to produce magnesium sulfide. So we're starting with a 5-gram strip of magnesium and we ignite it in a jar. And inside that jar, we have 0.5 liters of diatomic oxygen gas at standard temperature and pressure. I want to know how much of my product, magnesium oxide, I'm going to be making. But to do this, I have to know which one is the limiting reactant. I'm also asking for B, determine how much of the reactant is in excess and that's not going to be used or that's left over. So make your list of given and find. So we know we have 5 grams of magnesium and zero point 0.5 liters of oxygen. And we're going to find the mass of our magnesium oxide first. So in our steps, our first step is to convert our reactants over to moles. So that's what I did here. So these are 2 easy one-step conversions where I used the periodic table to find the mass of magnesium. So magnesium cancels out. I'm now 2 moles of magnesium. And make sure that you label these. And also notice I labeled this is, I have this much magnesium. I have this many moles of magnesium. Now I'm going to convert my liters of oxygen over to moles of oxygen. So I'm going to use the 22.4 liters to moles of oxygen, and I have 0.022 moles of oxygen. So this is how much oxygen I have, how many moles of oxygen I have. So our next step is going to convert to compare. So what does that mean? Okay, so technically you only have to convert and compare once, but I am going to convert and compare both of them. So this number, this 2.10 moles of magnesium, came from right here. Okay, so it came from this calculation here. So I have 0.21 moles of magnesium is what I have to work with in the lab. And I'm going to use my balanced equation coefficients right here. So remember, that's where the 2 came from. This is where the 1 came from. So I'm going to convert this over to number of moles, and I'm going to compare this. Okay, so this is saying I have 0.21 moles of magnesium, and I'm going to need 0.10 moles of oxygen for the reaction to take place. Okay, so if I look at what I have 0.022 moles of oxygen. I need 0.1 mole of oxygen. Okay. So this is where I'm going to drop down here. I have 0.022 moles of oxygen. I need 0.1 mole of oxygen for the reaction to take place. So do I have more or do I have less than what I need? So I have 0.02, I need 0.1. So I have less than what I need. So that means that oxygen is the limiting reactant. Well, just to make sure we understand this convert and compare step, I'm going to go on and take my moles of oxygen that I have from up here that I converted from my liters to my moles, and I'm going to convert and compare it. Okay, so I'm going to convert my moles of oxygen over to moles of magnesium. Okay, so this is saying I have 0.022 moles of oxygen. I'm going to need 0.044 moles of magnesium for this reaction to take place. So if I have 0.21 moles of magnesium, this came from right here. This is how much that I have. Notice this is why I'm labeling it. I have this much. This is what I need right here. So I have 0.21 moles of magnesium and I need 0.044 moles of magnesium. Ask yourself, do I have more or less than what I need? Well, in this case, I have more magnesium, and that means that magnesium is going to be in excess. So O2 is the limiting, magnesium is in the excess. So that's why I'm saying in this convert and compare step here, technically you only need to convert and compare one of your reactants. But sometimes when you're getting started and you're moving along, you may just want to convert and compare both of them to make sure that you did look at them correctly with what you have and what you need. So once you've determined your limiting and your excess reactant, you can use your limiting reactant to solve for other parts of the question. Okay, so in this case, they wanted to know how much of your limiting reactant, or excuse me, how much of your product, magnesium oxide, is going to be made. So basically, what you're going to do is start with what you're given. Okay, I know oxygen is my limiting reactant, and I know I have 0.5 liters of oxygen. So now this is just like our mixed steps with our double mole diagram, where we're going to go liters to moles. And notice this is 1 mole here because it's oxygen in the top and the bottom of my equality. So liters cancel. Now I'm going to go moles of A to moles of B. And this middle step, remember, is where your coefficients can be different depending upon what they are in the balanced equation. So here's my balanced equation all the way back here, 2 and 1. Then I'm going to go moles of magnesium oxide to mass of magnesium oxide. I go to the periodic table and I calculate the mass of magnesium and oxygen, add them up. So moles of magnesium oxide cancel, moles of diatomic oxygen cancels, liters of oxygen, it cancels, and now we have our mass. So we have 1.8 grams of magnesium oxide that is formed. So that's why we wanted to figure out first which one is the limiting reactant, because it's going to control how much of our product is going to be made. Now, for the excess reactant, basically what you would do is, I've noticed I did a shortcut here. So I know this is how many moles of oxygen I have. And we're going to convert that over to mass of magnesium because we're given 5 grams of magnesium. And this is just like using that double mole diagram. Most of the time, I would start with the 0.5 liters, but some students are thinking, well, can I do a shortcut and just go from moles of oxygen to moles of magnesium? And you can, but please, please, please do not let that get confusing to you. Okay, so sometimes it's just better to start with the 0.5 liters and do that extra step. That way you know which mole to use. And then just simply find your difference, and you know that you have 3.9 grams of magnesium that's left over or in excess, or that's not going to be used. Our main step that we're going to be working with is I'm not going to work out all of, I'm just going to not worry about the excess at this point. Just to kind of shorten things up with us getting close on time here. So we are going to look at our balanced equation. We're working with methane, and we're given 50 grams of methane, and we have 100 liters of oxygen at STP, and we're going to ignite it, and we're going to make carbon dioxide and water vapor. So first thing we want to do is determine which reactant is the limiting reactant, and then we'll find the mass of our 2 products. We'll find the mass of our water and the volume of our gas, and we're going to skip D for right now. So looking at your steps, we're going to first convert both of our reactants over to moles. So we know that we are given 50 grams of our methane and 100 liters of our oxygen. And we want to find out which one is our limiting out of these 2 and how much of our 2 products we're making. So our first step, like I said, is to convert both of these reactants over to moles. Okay, Okay, so to do this, we're going to convert our 50 grams of our CH4 over to moles. I'm going to use my periodic table to find the mass of methane, which is 16 grams. And this is going to be 1 mole because the substances are the same. So I'm going to end up with 3.125 moles of my methane. And I'm going to label this as what I have. So this is how many moles that I have of methane. So now let's convert our liters of oxygen over. Okay, so O2, there are 2 oxygen in there. We're going to go 22.4 liters of O2 to moles of O2. Not sure why I said 2 oxygen, but it's O2. That's okay. And whenever we convert our liters over to moles of O2, we're going to get 4.464 moles of O2. This is showing I have this many moles of methane and this many moles of oxygen that I'm working with in my problem. And the next thing I'm going to do, according to the step, is convert to compare. So pick either one, and we're going to convert and compare it. Okay, so I'm going to change colors and make this red here. And let's pick our first one. So this is going to be step number 2. And I'm going to take 3.125 moles of methane, and I'm going to convert that over to moles of oxygen. To get my numbers for right here, I am going to look at my balanced equation. So I have 1 methane, 2 oxygen. So I'm going to multiply 3 that's a 3. 25 times 2 divided by 1, and this is 6.25 moles of oxygen. Okay, so I labeled this one as need. So let's compare our oxygen here. Okay, so I have 4.46 moles of oxygen. I'm going to need 6.25 moles of oxygen. Do I have more or less than what I need? I have less. Okay, so that means that oxygen is going to be your limiting reactant. Okay, so I wrote this out for you. I have less moles of oxygen than what I need. So that means that oxygen is going to be your limiting reactant. So let's just convert and compare Our other one, where we convert and compare our moles of oxygen over to methane, like I said, normally you only need to do this step once, but just to practice with that more or less part, that's the part where students have to get used to that wording. Okay, so we have 4.46 moles of oxygen, so that's what we're going to convert. And we're going to convert that over moles of oxygen to moles of our methane. And we use our coefficients from our balanced equation from earlier. So it was 1 and 2. Okay, so right here, 1 and 2. So we end up with 2.232 moles of methane. Okay. Okay, so I labeled it, this is what we need. So we need 2.23 moles of methane. So let's go back up here to our first step, step 1. We have 3.125 moles of methane. Okay, so do we have more or less than what we need? So again, we need 2.232 and we have 3.125. So that means since we have more, that means that methane is the excess. Okay. So now we're going to go moles of CO2, and this is going to be a 1 here, to our volume, which is 22.4 liters of CO2. Multiply everything on top, multiply everything on bottom, so you end up with 2,240 divided by 44.8, and you're going to end up with 50 liters of CO2. Okay, so again, your first step is to convert your two products over to moles, because in lab, again, you're not given moles, you're usually giving mass or volume. So when you do that, that's saying how much you have. Your next step is to convert and compare. So take your moles of one of your substances, which we did here, and convert it over to the moles of the other substance. And this is saying what you need. So I did that with both the oxygen and the methane. Do you have to do both of them? No, you just only have to convert and compare one. So since we have 4.46 moles of oxygen and we need 6.25, we have less than what we need. So that's why oxygen is considered to be the limiting. When we converted and compared our methane, we have 3.215 moles of methane. We need 2.23 moles of methane. So we have more than what we need, and that's why that one is considered to be in excess. Once you know your limiting, then take your limiting reactant that you're given, so 100 liters of our oxygen, and then you're just doing regular stoichiometry using your double mole diagram of converting your volume over to your moles and then your moles over to your mass to find your mass of your water. And for your liters of CO2, you take your 100 liters of O2, convert it to moles, then moles of O2 to moles of CO2, and then moles of CO2 to liters of CO2, and you have how much of your liters of your product CO2 you're making.